Хочется проще.
And we would like to make it simpler.
Существуют проприетарные языки запросов, то есть есть
Because there are proprietary
о событиях безопасности,
languages,
специфический синтаксис, и
we need to be able to find out the syntax and how to fill up the syntax.
написаны
So the events that are written
экспертами для экспертов.
are written by experts for experts. We would like to make it simpler.
Технологии машинного обучения, так как
So the implementation of the machine learning also gets much more complicated.
также
So there'll be fewer experts, and also the operator may have
что
a lot of false positives, which will
в целом
enhance the load. We would like to make it
очень хочется. И начнем мы с того, что хотим получать данные естественным.
We would like to get the data with the natural language.
Идет общемировой тренд на то, что
So there is a general trend.
будет учить не то, чтобы какие-то языки
You may not want to learn the specific SQL language or whatever like that. Maybe you will not need programming at all.
что в будущем нам, возможно,
So
больше
in the future, we are highly likely to have domain knowledge because all of the
пытаемся также
programming will be about NLP
и в общем и целом наша задача
requests. That's what we are moving towards, and our task is simple.
проприетарный язык
We have our proprietary PDQL language, and our task is to make sure that the user who is not fully embedded into
наполнять,
context,
чтобы у него имелась возможность просто задать
you will have to have this opportunity to
данные.
ask this question and get this data.
Установлено соединение от хоста
So,
к
for example,
и вжух
the microtic connection from host to host,
может быть
and we have the filter.
15 тысяч.
And there may be more than 15,000 filters like that, so we may not be able to learn them all by heart, even for an expert, to say
Такое PDQ,
nothing
и
about
как вообще его
the simple user. So what's this PDQL is all about?
то есть
Positive data query language, the
то есть
CM system request language. So that's how we get
выглядит следующим образом.
it from CM. So here is the structure.
То есть это
First of all, we have the filter,
по которому мы хотим получить
the
события.
data source,
Через pipe
then through the pipe,
с помощью оператора select,
with the select operator, we get the margins we would like to get, and then through the pipe,
указан либо
we may have yet another filter,
и так далее.
limit, order, and so forth.
Так, собственно, в чем вопрос?
So what's the question like? Whether we need to learn, whether we need to train or not? Artem said that we have more than 15,000 filters like that in our system, and we are in between two ways. First of all, we train at this
сложно почему? Потому что очень
query response pair, because there is a lot of internal data. For each filter, there are certain fields that you need to fill out, and to fill it out is a very challenging task. So that's why we decided to do it differently.
надеюсь,
We decided to use RAG technology, retrieval admittal generation. We use LLM and additional context with our database
фильтров и полей.
and our filters and margins.
Так, собственно, какие данные мы имеем?
So therefore, what's the data that we have? Our data is the normalization data.
Это такой процесс
Normalization is a process in CM
лога из
for the non-standardized logs. It may be either a device
любой лог, который должен быть добавлен в CM.
or system that can be added to CM. And what's the data that we have? The source itself,
В первом примере,
like ID,
вендора Microsoft Windows,
the name of the vendor, Microsoft Windows, event log, the type of transport,
и некоторая маленькая summary, что вообще
and a short summary, what this formula really stands for. So out of these filters, we come up with a vectorized database with the embedded description. The second set of data is the margin, because not all of the margin is filled out for a particular filter. So we have a particular mapping. We have the field,
которые заполняются. И,
like
собственно, второй источник
5-10 fields that are filled out, and the second source is the value of the fields filled out.
А мы используем
So how do we check this. We need to use the reason and action approach, and in actual fact, it's just a wrap so that we make a more comfortable work. How does the interaction occur? The user sends a request in a natural language, like Artem showed. Then the agent knows that at this particular stage, he needs to check the keywords from the query and go to a vectorized storage for a relevant filter. They get a pack of filters, and LLM decides which filter is the most appropriate one. At the next phase, with having the filter selected, we have the filter. We have all of the filters, CM, the proper margin, and the user request.
Да, супер. И с каким инсайтом мы столкнулись?
And what's the insight that we have encountered? The insight is entitled Chain of Thoughts. LLM is the big language model, and 9 of 10 of our smartphones check the language that they generate, text they generate. So we'd ask the LLM to write what's it doing, like thoughts, chain of thoughts. LLM is saying, we would like to get a particular filter, and we see a user request, like, for example, please write PDQL with the margin line and source ID so that the users can be added to the GitLab group. And the user says, I need a filter at this stage, I have keywords at this phase, and we need to get it. Excellent, superb. We checked the embedded space, we checked the proper filter. Now we need to have a certain field. So now we have the fields, we have the margins, we have the filter, and the agent actually knows that they need to come up with the final answer.
Получился PDQL запрос в поле filter ID, то есть мы пишем конкретную, то есть через pipe select, и мы здесь видим, что
a request through pipe select, LLM recognizes that there is no source IP address like that, but by taxonomy we have the proper name, so it's shown it in a proper way. This request is validated and is sent and gives us data. The next point is actually the explanation of incidents in simple words, in simple terms. The cybersec events may be written through role-based and ML-based approach. Role-based is shown on the left-hand side. Like we have the name of the correlation, we have the rule-based description. But these correlations can be sent by a vendor or written by a user. The description to fully understand what is going on may not be enough. The similar situation is with the ML-based approach. We have machine learning models, and they have verdicts written by human language, but we would like to get more context in here. So what do we need to get? We need to get the data. The user at the front end gets this, and we would like to get the information through API, depending on the domain task. With the CM, we just need to get a map of the event with all of the taxonomy fields filled out. As for behavioral analytics, we just need to use the API for the events generated. ML of the models, that's what we would like to describe to the user. Then we go to the DB, where the correlation-related data is collected, plus some additional data, and we also have some small description of MITRE attacks so that we can come up with a proper response to the user. Now we have to come up with a prompt and address the backend LLM. We send the request there and we get a response. With the post-processing, we brush it up, make it look beautiful, and we give it to the user to the front end. What was the insight we faced at this stage? It was a very simple technique called few shot. We show the response and the answer to get more structured response. And we see the description of the rule-based approach. There is a certain correlation. In the first block, we describe what type of correlation this is. Then, what would be the danger for the infrastructure? In the third block, the LLM system says what the attacker can do if this correlation is engaged, and the inexperienced user may find it very useful. And then we can come up with a summary of the MITRE attacks. The same approach is with the ML-based. For example, we have a task host exe process. We don't know what this process is all about, and we get the explanation what this process is all about. Then we have some logical conclusions that may help user understand whether it's a false positive or an attack. Then we come up with a recommendation so that we find out whether it's an attack or not, and then we do some mapping of the MITRE attacks to explain what is going on. So now we would like to see that this should be done with the minimal involvement of a human being. How did we do it previously in terms of NLP? For example, the simple task is the classification of the text. We have an event, a security event in JSON. We have the name of the user and some other fields that look like a structured text, and we have a trivial task, whether it's a hacker activity or not a hacker activity. What do we start work with in this situation? We need to do the marking of the data. We need to get the set of events. We need to get a lot of experts to mark up the data. But we understand that if we take a mid-size organization, we get 10,000 events per second. In 24 hours, it would be billions. Then we multiply it by days and we get shocked. We cannot mark all of the events manually, by no reason. But imagine that we managed to do that and we marked all of the data, then we can apply the vectorization, the data, and we may use both the classic approach or more sophisticated neural networks methods. So with all these vectors, we can use the pathway from simple to more complicated. But can we do it differently? How do we escape this bottleneck?
Ответ может быть где-то очевиден, но и не очень. Можно попросить LLM, буквально.
You can ask LLM to do that, and you say, LLM, you are the most important expert here, so here's the security-related event, whether this event is a dangerous one. So maybe LLM can come up with a response, but sometimes the response may be unpredictable. If we get the responses of appropriate quality and an appropriate number of hallucinations is okay, you can put it on hold. But even with the small number of events, like 10,000 events, we won't be able to process each and every event with LLM. And I don't really mean the standalone company. Imagine OpenAI with a nice chatbot NPM service. You may have used this, and you may check out the server, and the server does not let you in, and they say, please come back later. And you say, okay, seems like the service is okay, I'll come back later, like in 15 minutes. But what are we supposed to do with a CM? In CM, there's a flow with 10,000 each and every second. You will not ask CM to stop and put it on hold. So any downtime is actually about spoiling this queue. So I think we should not put it in queue. But we can actually do the marking. In this pipeline, we can change the expert somehow. How can it be done? We can do it in a trivial way. For example, mark the target. We take it, give it to the experts, and we use the standard data annotation approach. But we have a more non-trivial approach. We get the text description that we use to find false positives. So how do we use the text description? In the operating systems of the modern day, there are lots of events running, and the processes launched and the analytics of the SOC of the frontline are supposed to know all of them, so that they know what is going on. And the LLM knows the answers to all of the questions. So there's a picture with types of processes. We launch 30,000 unique processes, and the user needs to understand what they really mean. It's true. So in actual fact, what are we supposed to do? We would like LLM to get the explanation why we need these processes. So we take ChatGPT and we ask the Explore.exe process what it uses, who utilizes it, and we received a high-quality text with proper answers. So that's what we thought about. What can we do using this text? Well, at least we can use them for interpretation. For instance, when we have the CM interface, when we have a process and we can put a question mark and get this information on the fly. The same analyst may get the explanation. So what's the task that we have faced in all these processes? There are plenty of them. We can hear and see here that there is a certain version, and we would like to make sure that we cancel these processes so that we do not generate a lot of similar texts for different versions, but just get one and send it as a universal one for all of the examples. But we have an assumption. Our system needs to have a certain intellect, and such processes like 7zip, PackZer, and other ones, their names contain the name of the algorithm, but not the name of the version that should be checked regularly. For these examples, we do not need a regular expression. So what have we done here? We've used LLM.
С каким инсайтом мы столкнулись на этом этапе? Инсайт, подумай
еще.
То есть мы получили некоторые...
Again, we received JSON, we parse the LLM responses, and we get examples like 7zip.
Ассистента нашего нет.
The answer is no, and for the regular expression where it's required, like Python and Chrome installer, we got proper patterns. So what's our advantage here? Well, first and foremost, we can check in the code whether it's a proper expression or not. If we receive this in a proper way, the pattern is the same, but if the pattern is different,
Ну, собственно, это и не так важно на самом деле, потому что...
It's different, but it's not so important because all these data Annotation is done in data very flow. The model may hallucinate and we get some additional explanation, but it's okay. It will cover like 90% of all of the processes, but it's also okay. We did not put any effort into it to come up with the regular expressions and come up with the daily routine, but it's great. How can we use this to fight false positives? Here we'll consider one of the models that we have this in the behavior analytics, the recommended system which detects the abnormal launch of the process by a regular user. We spoke about it in details last year at PhD conference. If you like, I may check it out. So how does this model work? It's real simple. We have Sysmon1, which creates the process. We have users that launch these processes, and we can come up with a matrix of their interaction. The user launches the process, and in this matrix we'll be able to train the model, the recommendation model. But the question is, how do we adapt it to the task of detecting the abnormal behavior? Actually, the description of the users that we received thanks to that matrix can be interpreted quite vividly, like we see on the slide. The back office, the programmers spoke about that positively, and we knew that it works quite well. So how do we detect anomalies? At each moment in time when the user launches a new process, we set a recommendation to the user, and we see whether this launched process matches with our recommendation. At that moment in time when the error starts growing in our algorithm and we understand that something is going wrong and the user is launching things that they're not supposed to launch, we signalize about it. Very often there's a question that the name of the process can be easily substituted, but our behavioral analysis model has 52 models, and we have models that can detect such masquerading activities. Yes, and how do we use our description? We actually received these data annotation for all of the processes. How do we use it for our RecSys? RecSys detects abnormal behavior quite well, but it's an ML model, and they all have quite a lot of false positives. So our task is to reduce the cognitive load on the operator. So we need to reduce the number of false positive events. The question is, we have all of the texts and we can have the embedding, and we reflect it at one plane, whether we can compare the processes with one another. And here I'm showing the three types of processes: develop, office, and system. And we can see that yellow window processes come up in the form of a cluster. So their descriptions are very close and they are nearby, close by. But on the left-hand side, you can see the develop category. Poetry, Python, for instance, and other ones. Python is everywhere in development. So they are also in the form of the vicinity, in the same group. So it's all related to development. And we have other insights like Excel, WinRAR, office-related processes. So we think maybe we should check the processes and the vicinity around with the processes nearby. How can we use these processes laying nearby? We can use them for such particular cases. For instance, we have a developer, a great developer, let's call him Vasya Vasilyev, John Smith. So he launches three processes, these ones, kubewise, SSH, exe, etc. So those were new processes, and our rec system says that that's an attack. That's obviously an attack. At this particular stage, we used our content-based solution. We checked the vicinity of the JRE8U383 process. surrounded by Java, exact Java setup. And we remember that Vasya Vasilyev is actually a developer. It's okay for him to launch such things. So it's not an attack, it's a false positive. So with the cube-wise process, it goes the same, like cube-wise, cube forwarder, cube linter, etc. And it's not an attack either. The same applies to SSH. Vasya launched other processes of the similar kind, like SSH, etc. So we mark it as an okay move. So, making a summary of our presentation, we should say that we do everything to make the user experience better and simpler. We try to get our data in a natural language. We try to explain to the user what is happening in a simple language. We try to minimize the involvement of the experts in the data annotation, and we try to reduce the load to the operator. Thank you very much for listening. We have an excellent ML team. We're in search of talented developers and engineers. If you're interested, please use our QR code to learn about our team, and please join us there. We are waiting for you.
А какие-то это самые вопросики будут?
Есть вопрос?
Can we expect questions, by the way? Do we have questions?
Так, где наш организатор Алексей?
А может, симпровизируем тогда, если...
Alexei is not here, who's supposed to bring the questions. I think we can improvise here. You guys can grab a mic and ask the question from the floor, just for the time being, before the organizers come back. Hello, thank you very much for your presentation. It's interesting, indeed. It's a very interesting topic. It's a topic that interests everyone. I'm Oleg Zhulin from iTech EQ company. The question is, in the machine learning, it's the data which is important that we use. There is an expression, shit in, shit out. You have the automated data annotation. Do you compare the manual data annotation and automated data annotation? Does the quality reduce significantly? Well, the answer is simple. The quality goes up. When we speak about data annotation, we speak about that as processes. Previously, we had a name of a process that can be faked, but now we have maybe it's a general-based approach, but we have more or less correct approach, and we reduced the number of false positives. We do not use this in our pipeline for manual data annotation. We said that you can try doing it, but in actual fact, we did not do it ourselves.
Давайте мы зададим вопросы из бота.
I think we should ask questions from this bot.
Мы скучали. Вот.
We were missing.
Решается ли проблема мульти-хоп вопросов?
Multi-hop requests and the risks revealed by the users of the uncertain scenarios of okay. Do you resolve the issue of multi-hop requests? Well, the explanation of the incident does not imply that the user will ask questions initially. Together with experts, we come up with a pool of questions which we prepare in the form of fronts, and the user needs to press the button to send it. We send it to LLM, get the response, and the user does not have this magic button to ask a question.
Вопрос, насколько критичны ошибки при
Next
генерации
question.
фильтров,
How critical are the errors when generating the filters? Because the user may have not enough competence to identify the hallucinogenic behavior of LLM. Do you use any quality metrics to identify the result? With the PDQL responses, we have a certain Easter egg there. We get 10 different relevant filters, but LLM selects the best ones. But in actual fact, the user has an opportunity to change the filter for a second filter or a third filter if the first filter was incorrect. Quality-wise, we make a validation selection with the 100 examples. It's difficult to generate these PDQLs. However, we did that and we tried to evaluate the quality, and out of the 100 examples, 93 examples out of 100 were mapped exactly, and it's a good output, and we continue working on it. We're happy with the results we have achieved. An interesting question. Your examples showed ChatGPT. So another question related. Do you leak the data? No. Please explain. We have our own self-hosted model. Can we disclose it? No, let me start answering. We have a pipeline of working with LLM in general, so we don't start with open source solution. First of all, what we can leak, we leak. We test it with the ChatGPT, for instance. Then, with the anonymous data, we know that everything works and it operates properly. Then we provide an appropriate quality with the minimal use of the resources. And the type of the model doesn't really matter, by the way. Code Llama 34B and Mistral for explanation. So that's the legacy. It's okay. But if we would like to clarify, you said that there was this proof of concept and you used the third-party solutions like ChatGPT, and you said that obfuscation and anonymization occurs. We do it manually. Okay, I understand. But of course, we can use a more complicated way, but sometimes we do it manually as well. Another question. Will you share prompts with us? No. So then I will ask this question in a different way. Will there be a way like API or something like that, or we need to tune it to match the results? Well, we actually consider it as a prod, not that every single customer will have an mGPU cluster, but can they do it, basically? If they have the resources, they can do it, and obviously there'll be no problem. But the initial concept is that we make these clusters, and those users who can get internet access, they may want to have this feature, but if they don't have this access on-premise, they can do it on-premise. Why not? Another question, interesting one. Will you detect malicious processes that can be camouflaged for legitimate ones? Do you detect them by the names of the processes? Aren't you a hacker? Are you surely not a hacker? I can send his nick to you, nickname, the author of the question. These processes can be camouflaged as legitimate processes. We check the name of the process. That's the task of the model. There's another model that can detect that the hash has been changed or the hash remains unchanged. So apart from that, there are plenty of other ones. that can detect this. So the question is from me. You have a set of expert models. One model pulls to one side, another one pulls to another. If one of the models would said that it's malicious, what do you do? By voting or what? It's our module of behavioral analysis. We have this low-level model. They detect it at a low level, like an anomaly, abnormal behavior, but it's not an alert as we announce it. We consider it as the vector. We can see that there are 25 models, and their vectors of initialization is there. If the model 1 and model 2 are initiated, it earns a certain number of points of risks. So we would like to get an even better ML model. We understand how hackers acted in the infrastructure. We would like to check how atomic models work. So basically, you're currently measuring the scores. Oh, we obviously have a lot of questions. Let's go back to the presentation. LLM. What kind of LLM did you test? Maybe you used GigaChat, maybe you used Sberbank solution, maybe you used Yandex solution. Maybe you tested that on the cybersecurity domain. We used LoRa for a very targeted purpose. We took that as GPT, and we used those solutions that we could run. CodeLana, Mistral. Previously, we had the Mistral 7B extract. It did help us resolve those tasks. And we conducted experiments with LoRa at a certain domain. But in order to get the annotations for processes, we just used the running model with a prime time, and we also tipped LLM, and it was fine, but further on we will develop this solution. We'll tune it. We started with even simpler solutions. We had a chat GPT. We asked it to generate the couples, the pairs, question answer, and we trained T5 to do that, and it pulled it off. It would have been much simpler and easier, but there's a subtlety here in terms of user experience. If we train T5, which just gives a certain answer to a question, we cannot continue a dialogue with it. Please correct me, please do it better. So if we use this approach with more serious models, we know that we can add the function of the chat on the fly. There are so many questions about LLM. I would like to wrap it up. First of all, you use ChatGPT to check the hypothesis for the data, anonymous data. Data is anonymized by person manually. CodeLama, Mistral, you mentioned you use them, and you are currently, you do additional learning. Yes, we do that. History develops, and LLM develops as well. Do we have any other questions? Yes, please.
Ну, раз уж начали, почему бы заканчивать?
Добрый день. Меня зовут Александр. Спасибо за...
Hello, I'm Alexandr. Please speak up. Speak up. In your presentation, you showed the data from Sysmon. In actual fact, these are standard monitoring solutions of the infrastructure. If the customer uses their own homegrown custom solution, if they would like to use the business app, is your model ready to use that?
Потому что у нас есть
It's a great question.
параллельная задача,
In parallel, we run an
генерирования
extra task
нормализации,
to generate
новых
the
источников CM.
normalization
Такая
form,
бизнес-история,
and we
когда
add
есть какие-то новые
different
логи,
CM.
нужно тоже добавлять CM.
There are different logs that can be added to CM. We find
Это вообще, ну,
abnormal
другой вектор, который
behavior,
мы очень активно
make
сейчас
correlations.
развиваем.
It's a different vector which we actively develop, and we also have some excellent results there. I think next year we'll make a presentation and speak about it.
Продолжать именно по этому вопросу, то есть если приходит какое-то другое событие, опять же, две стороны.
About your question,
То есть что скормить в LLM,
it's
как будто бы разницы большой нет. Но если смотреть
two sides of the coin.
продуктовых решений, то есть
LLM is one thing, but if we take,
поведенческого анализа,
for example, the behavioral analysis module, if there is no sysmon, it's a bad thing. You just need to install sysmon for that.
Может быть что-то другое, что
My
заменяет.
question is about
И,
things that may replace sysmon and sends the same events, but in a different format with different ID. There may not be different ID in CM. We only work with the sources added. So before we add some other log, it should be normalized, but it's a different task. We can only search for the things we have.
Тут вопрос,
Thank you.
какую
Here's a question.
для
What's the language model for embeddings
вы использовали?
Прям конкретное название.
did you use? You want a name? Yes, the name. I don't remember. It's okay. But did you train it? Did you make it learn? No.
Просто
You just took it as it is. Yes.
к тому, что, скорее всего, название процессов
So obviously the names of the processes are very, very specific, but the models are trained and learned at the natural language. Yes, we have the description at the natural language. There is nothing very specific in there.
описание фактически.
So that's based upon the description.
Супер.
просто думал,
Окей.
как текстом потом еще в эмбейзинге докидываем. Не, ну а так просто если посудить...
In actual fact,
специфические процессы,
there are specific processes. They may be much more complex.
и текст, скорее всего, хороший какой-то сгенерится. Но чаще всего у нас процессы, ну, они действительно могут быть там...
Very often the processes may be very
там, по HR,
trivial, CMD, exe,
достаточно для обучения.
etc.
Наша главная цель снизить
Our main target for us is to reduce the cognitive load on the operator. We would like to make sure that the trivial processes are automated, and very specific things
и мы будем
will, of course, remain, and we will work with them.
Еще
Excellent.
Эксперты, для которых это делать, они
So the experts are happy.
По-разному.
Do the experts like that? Like it? It depends. It depends.
наверное, последний у нас будет вопрос.
I think one final question to you. Looking for anomaly.
С повторным запуском процессов.
How do you eradicate the relaunch of the same processes?
описание или как модель детектива?
Не, как сама модель рек-системы. Кажется, это просто не является проблемой, но оно уже запускается.
I think it's not a problem.
Значит, мы на этих данных
They are launched frequently. We use this data of launches. We can learn using this data. The similar processes are launched and relaunched in the system, and there's a certain vector.
Если так, у нас есть
It could not be just
то есть если
the same. We have
получаем
caching mechanisms. If we have the
то есть мы используем
similar launches of the models, we use the cache
касательно самой рек-системы.
for this process. And as for the rec system,
Если вернуться
how do we eradicate that? If we go back to how it works,
проблемы, которые были названы, они
the problems that you mentioned
не являются. То есть
are not problems for this particular algorithm.
вполне конкретные
We get the
мы обучили модели,
training
процессы,
selection,
у нас,
we get the model, the processes.
пул процессов,
We have a top of processes that are launched much more frequently. So even if we miss somewhere, it's okay. But even if we miss all of the 10 or 20%,
очень коротко.
an anomaly occurs. That's briefly saying. I think this is it. For you, you just need to select the best question.
один или два надо
But we don't remember all of them.
выбрать нужно один.
How many questions can we select as best ones? Just one. But there were lots of questions. Maybe you asked some of the questions that the people liked from the floor.
Давай.
The normalization formula related question. But what if that person says no?
Все, подходите.
No, we like your question. You win the t-shirt. Please come up to grab your merch. Thank you very much for listening, and thank you guys.